Well, good morning, everyone. My name is Eric Walters at Somerset Community College, specifically the Additive Manufacturing Center of Excellence at SCC, and I appreciate the opportunity to get to talk to you all today about the economics of what we do and additive manufacturing, 3D printing, and how we can actually work with you all at the cabinet for economic development and see Kentucky grow from this great opportunity. Just to get the process going, and there we go. What we're going to talk about is the technology itself and why it matters to Kentucky and the barriers that are inhibiting Kentucky from being able to take advantage of it. And just to give you a quick background on myself, I'm doing engineering, architecture, that type of work, and our overall goal with this is to design the products of the future, and not only just the products, but the construction and the housing and just the next generation technology that we can use with this. We are part of the Kentucky Community Technical College system, the 16 sites around Kentucky. We're located in SOMERSET, right next to Lake Cumberland, and this is where we house all the technology for the curriculum development and getting it out across the state. So we have all the high-end equipment, the low-end equipment, develop the curriculum, the education process, and we push it out. So what our overall goal is, our mandate, our driving force is to spread additive manufacturing, often shown in here as AEM, or also called 3D printing, to spread it across the state as quickly as we possibly can. The fact is this technology is groundbreaking and cutting edge and making changes everywhere, but on a state level here in Kentucky it's not. So our goal is to get it out there. And why does it matter? Why are you watching this presentation? What's at stake? The answer is these four things. Jobs, of course, production contracts. We're also interested in helping to influence the location of new manufacturing plants and innovative business startups. All of that is tied into this technology. But to get the ball rolling, we have to ask ourselves one big question. What is Kentucky's largest export industry? Now, you all in particular would be more familiar with the answer to this. You know it, in fact, as being aerospace. A lot of folks in Kentucky don't. They often go to agricultural products. They will say things like the automotive. But at the end of the day, we're talking $32 billion. In terms of overall, we're talking roughly 13 billion of that is aerospace, and the number two, automotive, barely a third of that. So it's a huge, huge component to Kentucky, and one that we need to be aware of and what's happening in that industry. Specifically, the risk for Kentucky in having our entire, majority of our money being made off aerospace is the risk. And the risk is the companies we work for, these aerospace companies, they're starting to ask themselves a specific question. They're starting to ask the question, is additive manufacturing equal to money? And does additive get me more money or savings? And here's what's happening. These companies that we technically work for, these ELCs, your GEs, your Boeing, your LOCKHEEDs, the companies that we operate, they're asking this question. So before we get into the answer to the question, we first make sure that everyone understands what additive manufacturing is, or 3D printing. Again, we use those terms interchangeably. But as you see on the screen, there's several applications. There's the typical desktop units that actually produce plastic objects. You can actually 3D print in metal and different variations of that. There's even construction printing that's just so huge you can build buildings. But it basically works like this. You take some type of design file. Maybe you design your own coffee mug. Maybe you download a design file from the internet. You take that design file and you run it through a program called a slicer, and the slicer looks at the object and it turns around and writes code to tell a 3D printer how to make it. So it's a three-step process. Design it or download it, put it into the slicer writes the code, and then you turn around and put it into the 3D printer and the printer makes it for you. So keep in mind, it's a very, very straightforward process, and just requires a technician. As long as you have a design file, you can make it. Now, the technology has been around for quite a bit. However, we had what's considered the hype cycle occur around 2012, 13, 14, when everyone got really excited, some patents expired, and people got really excited about what the technology could do. Some new startup companies popped up onto the market, and then quickly crashed out. the trough of disillusionment when they realized it wasn't what we thought it was going to be. The difference with this technology and everything else is that we are in the slope of enlightenment and the maturity phase a lot sooner than expected. We're already making our way up that slope right now into the plateau of productivity, way faster than any other technology that we're aware of. And so the question is, does the ELC, the company we work for, they're asking the question, does it make them money? So here's the answer. Companies start going out and asking that question, and they turn to their internal departments and they say, can we 3D print something? Turns out GE is one of these companies that asked this question, and here's what they did. They decided to try to 3D print one of their fuel nozzles in their cutting-edge engines. Right? It's a nozzle they used to make. The whole system itself is assembly they used to make, with conventional manufacturing. And turns out the answer is yes, they can actually 3D print this thing in one shot. What was interesting, though, is not only could they 3D print it, but that when they 3D print it, it's 25% lighter in weight. When they 3D print it, it's 5 times more durable. When they 3D print it, they no longer have to have 20 parts assembled. They can 3D print it as one single unit. When they 3D print it, they can make tens of thousands, 35 to 40,000 a year. And not only that, when they compare the data, they say, okay, you know what? Our part weight goes down. You can see it in the green versus the blue. Our manufacturing cost goes down. Our life cycle cost goes down, meaning that it is more sustainable than the previous way that we made this fuel nozzle. But here's the catch. Their inventory costs go down. And the reason for that is very straightforward. They no longer have to inventory something that can just be printed on demand. And that was an unseen cost savings that no one was expecting, but incredibly significant. What do? They set up a plant to start 3D printing these fuel nozzles. And this fuel nozzle is not a small part. This is a pretty good sized part that's already in production and has been in production because this first study was done back in 2013. And so what happens is after this first experience, companies go on. So GE turns around and says, we could do this fuel nozzle. What else could we do? What else could we 3D print? Turns out in this new turboprop engine they have coming out, it has 3D printed parts all over it. In fact, what they did was they were able to eliminate, and I mean eliminate, 855 parts and replace them with 12 3D printed parts. Overall result, the engine itself is a 5% weight reduction and a 20% improved efficiency on mission fuel burn. That's a huge deal. What else do? They go on further. They say, okay, we have this one thing that we are making out of 300 pieces, and we are taking 16 engineers to do this. We're taking 50 different manufacturers to provide those 300 parts, and we have all these data systems and everything to make this happen. I wonder if we could 3D print it. Turns out we can. It turns out that this entire part, this 300 parts, can be 3D printed in one shot, and it only takes 6 to 8 engineers. It only takes one system and only one manufacturing source, and that is one 3D printer. And look for yourself. Make the call. On the left is the old way of doing it. On the right is the new way of doing it. And you ask yourself, which one looks more like cutting edge? Which one looks more like aerospace? On the left, we have something that looks like it belongs in 20,000 leagues below under the sea. On the right, we have something that looks smooth and complex and cutting edge. And it's pretty much a no-brainer for an executive to make a decision. They'll go to the engineers and say, is it equivalent? And they'll say, the engineer may say, well, actually, it's not. It's actually way better. And the executive will say, well, is it faster to make? Yeah. Is it less cost on us? Yes. Executive says, let's do it. And so at the end of the day, the 3D printing allows them to print from the inside out, make products without having to assemble them, and make them more robust. So more externally and internally complex equals better performance, next generation design. And GE's not the only one. GM made the same kind of study. They said, we make the seatbelt bracket out of 8 parts. I wonder if we could 3D print it as one. Turns out we can. 40% lighter, 20%. So at the end of the day, what you have to realize is that these companies that we work for are seeing the dollar signs in additive manufacturing. And they're not stopping with just a little test out of just to try it. They are actually doing it. And so what's their overall response? GE turns around and drops $2 billion in buying up 2 metal 3D printing companies. They roll out a new engine for the Black Hawk that has a 161% increase in range. Airbus says our buy-to-fly ratio is flipped because now I can buy a bag of titanium powder and print off titanium parts instead of buying a block of titanium and carving out a part and wasting all of that titanium. So the buy-to-fly ratio has totally flipped in cost, and so they're saying we want to 3D print as much as possible. They have cabin parts, they have mission-critical parts already in flight right now. Their helicopter wing says, you know what we're going to do is use additive to produce parts that are 45% lighter and 25% lower in cost. We're going to have 2,200 parts in 2019, 2020. We don't know how many they're doing, but they've already moved into it. Some of the major aerospace and automotive manufacturers, GKN, for example, has 90% of their products in aircraft around the world, and they make this statement, we can now more cost-effectively produce tools for operators within 3 hours. 40% reduction in material waste. Now, they don't give us much more data in terms of how much money they're saving. They're keeping all that quiet, but they're just showing that they are integrating and it has major benefit. Companies that actually do titanium parts, same story. They buy less titanium, they get more parts out of it. It's just plain math. And so they are buying up metal 3D printing equipment left and right. Honeywell invests around $15 million in a company in Centivia down in Florida for a new facility to produce mission-critical aviation, spacecraft, and defense applications. BMW already has 3D printed parts already in the i8 Roadster and is adding on their third 3D printing facility. They've already done 1 million printed parts. In fact, one of the more recent ones was one that was developed in 5 days and implemented because of 3D printing. They've increased 42% in terms of their 3D printing production over last year. It is happening. Now you take a look at Kentucky where we have a lot of these small, medium-sized machining companies. Let's look what happens there. You take a part like this. You have a 3D printer compared to a conventional CNC system of making it. The CNC cost of making it, almost $1,100, almost $1,200, and it's going to take them 2 weeks. You're going to 3D print it, it's going to take you $64 and 3 days. And those kind of stories continue left and right. CNC cost for this part, $600. 3D printing cost, $60. 3D printing time to do it, 3 days, 2 to 3 weeks if you want CNC to do it. And you can see $210 versus $41. 3 weeks versus 3 days. Again, it falls into the no-brainer category for companies. Indeed.com posts jobs on 3D printing, and this actually happens over in Charlotte, North Carolina. A company called Orliken, they spent $55 million, and these are some of the job opportunities that involved additive. 107 positions for $100K in terms of an additive manufacturing business developer. 23 positions, 50,000 or more for those who had experience in additive. And no telling how many positions for CNC and additive applications if you understand the technology. And again, you see these things happen all around. Lockheed Martin 3D prints now their titanium satellite fuel tank for a tune of 87% decrease in schedule time. Cut their delivery time from 2 years to 3 months by 3D printing it in titanium. Bugatti, now don't get me wrong, with a multi-million-dollar car price tag, you can actually do a lot of experimentation, but they now have 3D printed brake calipers. That's what's taking this car from 200 miles an hour down to 0 really fast. And you'll notice they're printed in titanium, lighter and stronger, and they're the most powerful brakes in their class in the world. And a good sign that this is actually effective is that when other companies start to do it. So not only is Bugatti do it, but another company pops up right after them and says, well, we're going to print brake calipers too and sell them to your competition. And you look at the automotive industry in general. Ford desires that 100% of their engineers be capable of additive manufacturing design. GM is already in the training process to retrain their engineers for additive manufacturing. And here's what it boils down to. If the companies we work for are training their engineers in how to do design for 3D printing, what do you think the contracts are going to look like? Again, it's a no-brainer in terms of what is happening. Ford already points out that we're already in the low volume production. They want to get near to mid volume, which is, going from hundreds of thousands of parts to millions of parts to multi-millions of parts. But they want 3D printing production. There's just too many benefits. Lighter, faster, stronger, on demand, exotic material capability. It doesn't make sense for them to stay the way it is. GM's trying to find a way to upgrade its 2,300 contracting companies to get into 3D printing so they can actually send more contracts their way. Department of Defense, you can't speak enough about all the transitions that happen. We've seen everything from this $3 million deal up to a company in Ohio that specializes in legacy aircraft parts, which is something that Kentucky makes a lot of money off of, recreating parts for legacy aircraft. And their argument was, what, we normally get this part, it takes us $50,000 and takes us a year to get it. I wonder if we can 3D print it. And the answer is yes, we can get it for a fraction of the cost and we can get it in 1 week. There's no argument in terms of the Air Force. That means they will do it. You look at what is actually happening on the ground, even for modern day craft. Here's a great article with the Marines. They actually replaced a part with a 3D printer that typically costs $70,000. They printed, recreated what they needed for 9 cents. And there are already hundreds of parts. They started off with 80 or 90 parts that are currently in their database they can print. It's gone to the hundreds and heading to the thousands. And that is across all branches. The Navy's actually gone down to Oak Ridge and teamed up and used their giant metal printer to print a submarine. What used to cost $800,000 to develop now costs $60,000. What took 4 months to produce now takes 6 days. And here's the crazy thing. To do this project, they sent their engineers down to Oak Ridge. They spent about a week there. They turn around, they go back, they spend about a month designing, they send the files down, and there is the mini-sub ready to go. It happens that fast. The Army already has approved contracts where they are not only 3D printing replacement parts, but they are optimizing the design. You see down on the bottom of the screen, the part on the right is the old way of doing it. The part on the left is the new way of doing it. It does the exact same job, but it's print on demand and it's lighter. And you just can't get past that particular logic, especially military. It's lighter, faster, stronger, and on demand. You look at the Air Force, they already have as many parts as they can produce. In fact, some of the chief purchaser for the Air Force is almost fanatical for 3D printing as much as possible because it saves them so much money and so much time, because the military sees the supply chain, especially after COVID, the military sees the supply chain as being one of our greatest threats to national security, to actually get stuff. And so now we're introduced to a piece of equipment that you could actually have on site, have in a ship, have in camp to produce what you need. It is a complete no-brainer for colonels and admirals and all the decision makers to go with this approach. And you'll see that too. You'll see general after general talking about how on-demand production, on-demand additive is where they're going, and the contracts reflect that. The Army throws $20 million at Rock Island Arsenal to get into 3D printing and reducing the lead times from months and weeks to even days. So we'll go a long way to maintain overmatch. That is the threat to national security, is that supply chain, and this is one of their primary solutions. And then you start tracking investments. You start looking at what happened. Warren Buffett, the Oracle, just dropped $6 billion into Japanese companies. He now has 5% of Japanese 5 biggest trading companies. All 5 of those companies have heavy additive manufacturing presence. You look at this company, Velo 3D, raises $12 million for a total of $150 million in funding for metal 3D printing. Xometry, who actually bought up a company in Lexington, just got another $75 million to meet on-demand metal additive manufacturing. We just found out from, Fast Radius up in Louisville. They actually they can't even keep up with the demand of their work. They're buying more printers and bringing in more people. The expansions just keep happening. In fact, if you look at this, these are companies that have raised millions of dollars during the COVID pandemic. While everything else was going south, they're actually having investors pour in because the supply chain broke and 3D printing stepped in. And you see a lot of this. You see company after company putting funding into new equipment, bringing it to new locations, You see the DoD gave another $25 million to Defense Manufacturing Community Support Program. Kentucky received none of that money. Dyemansion raises $14 million to drive the transformation of AM. And you will see that a lot too in the articles that are being published, is that there's a big push to speed additive up, get production ready, do post-processing, part validation. All the money is being forced into additive to get it up another notch or two so they can go to faster and faster and faster production. And then you start seeing the investments. FAA puts $3 million into Auburn for additive manufacturing research. GE Aviation invests $50 million into Auburn for 3D printing more of their components, the fuel nozzle and a new bracket system. Then you see Carpenter Technology opens an Alabama AM Center. You see a lot of money going into Alabama right now about aerospace and 3D printing. Lots of money. GM puts another $7 million into move from prototyping to tooling. They purchased another 17 high-end 3D printers. You see company after company that is buying up smaller 3D printing companies so they don't have to reinvent the wheel. They can just acquire the company to get what they have. These mergers and acquisitions are happening just year after year and even increasing. So where does Kentucky stand? Where are we? All this money is being spent. All these advancements are happening. Where does Kentucky stand in the middle of this? Are we getting to take advantage of this? Are we part of this process? Well, here's a great way to get a grasp on it. In May 2019, we did a search for all of the military potential contracts that had additive manufacturing as the basis of those contracts. In our quick search, just for that month, there were 10 DoD contracts for manufacturing that involved additive. 10. Guess how many Kentucky got? Not a single company in Kentucky, as far as we know, even put in for them. And some of them were no-brainers. Some of them had already been done with another application that would have been a very easy switchover. And yet no one in Kentucky was competing for these contracts. 10 lost DoD contracts just because Kentucky wasn't ready for additive. And to keep the process in mind that 3D printing is not the same thing as conventional. It's a completely new thing. It's not like an apple-to-apple comparison. We often say it's like an apple to this new fruit this exotic fruit we could never reach before, and now we can. Because it's about next generation product design. Take a look at the parts there on the screen. You see all that lattice structure? You see all those curves and everything? That normally drives up the expense ridiculously high if you're going to go conventional manufacturing to the point of impossibility. But with 3D printing, with additive, it loves complexity. So we're talking about lighter, faster, stronger products. Here's a company we're all very familiar with. Some of you, especially across the state, know this company very well. They're doing some great investments in Kentucky. But here's the story. Stanley Black & Decker was one of the companies that actually asked that question, could 3D printing do some benefit for us? Here's what they found out. They had the part on the left. It's actually 4 parts. It's an assembly that goes on like a post-road driver system. It takes 4 parts to make it. 2 bolts, 1 plate, and then 1 base piece for a hydraulic component. It has to be 4 parts because you can't CNC from the inside. So you have to make the CNC channel, then you have to cover it, and you have to bolt it together. The question was, could we 3D print this in metal? Turns out they can't. The part on the right, 3D printed. And what do you notice about the part on the right? It's only 1 part. No bolts, no plate, no assembly required. Think about how much that takes out of the process. Removing the assembly removes a lot of labor, health insurance for that labor, controlling the climate for that labor, the building itself. There is a lot involved with that labor that is no longer required, and it's tremendous savings. And look at their data. The part itself, 53% lighter. Cut their lead times to produce the part by 98%. Cut their cost by 92%. Again, no-brainer for the person in charge. They actually went on, before I go on the next slide, they actually went on and did another part just to make sure this wasn't a fluke. Same story. cut their costs by ridiculous amounts, cut their lead time by ridiculous amounts, and what do? They go out and they start buying up metal 3D printers because you just can't. Now, do they pass that savings along? Not necessarily. But does that change the dynamic of who they're hiring to do the work? Absolutely. And in fact, if you do some deeper research, you find that Stanley Investments, basically their venture capitalist wing, of their last 10, I think it's actually Stanley Venture or something of that nature, of their last 10 investments, 7 of them have involved additive manufacturing in some way, form, or fashion, or generative design, which is the next generation stuff that we'll talk about in a second. So the company, another company that we work for, is heavily transitioning. Another really great breakthrough, check out the Riddle helmets. From the outside, you see on the bottom left of the screen, they look normal. But on the inside, they are 3D printed with a new cutting-edge approach. It's actually designed off the cranium of a woodpecker because it kind of reinforces on the backside to help reduce concussion. And you look at that super complex mesh, can only be 3D printed. And so they have 3D printers in the background making this mesh. We actually have some of the material in the same kind of concept here in the lab. And this, one of those DoD contracts that Kentucky didn't get, it was essentially this project, basically making new cutting-edge helmets for the Army. And all they had to do was turn around and re-pivot basically the Riddle project into that. It would have been super easy. And that's actually what happened. We found out from later on that that's who got it. That's what they did. And the big picture, lighter, faster, stronger. Lightweighting is crucial. Part consolidation is crucial, like with Stanley, like with GE, like with GM. This technology allows for lightweighting, part consolidation, easy customization, on-demand production, and that's why we keep saying next generation product. We just don't have the option to do otherwise. And so we'll give this a shot. It probably won't play. I'll see if it will. 1 second. So generative design actually allows the part to go from a big bulky thing, this is the GM part, down to an optimized design. Using artificial intelligence, it produces about 60 different options in terms of selection. You choose the one you want, you send it to a 3D printer, it makes the part, and it replaces the way we used to do it. And I'll take a few moments to describe this technology just a little bit more. From an engineering perspective, it outdoes me day in and day out. My degree's in mechanical engineering, and I have license, and I've been doing this for years, and yet it will outdo me in terms of quality of design and functionality and efficiency time and time again in minutes, 10 minutes or less typically. What would take me weeks or months to produce, it can do in a matter of moments. This is where the technology is going for sure because it's just better, lighter, faster, stronger. So your takeaway, pretty similar and straightforward. This is actually a great quote from GE, from Greg Morris. He says, I think in an interview, he said, I think you ignore additive manufacturing at your own peril. And for Kentucky, that's true. We rely on the contract work, and the contracts are going to be looking a lot different. Actually, are already starting to look a lot different. We've already seen that. We've already missed 10 contracts that looked different than what we could do, and we missed out the opportunity. And it's just going to get more like that. So the point is, additive manufacturing is now. Whether it's aerospace, automotive, they're all doing it. It's not a question. That ship has sailed. It is happening. But we see of all these investments, we're being passed. Down in Florida, North Carolina, Ohio, Indiana, Tennessee is getting a ton of investment and companies doing this. Kentucky, we have a couple little hot spots, like in Louisville, maybe a little bit, but that's about it. It's not grand scale. It's not happening across the state. And we are falling behind, even though we potentially could be the lead. So what's our plan? At Somerset Community College, our overall goal and our mandate funded by the NSF and the USDA, Perkins, and all of these other groups, our mandate is this, is to stop this and change the direction all this is going. We call it, our acronym for it is AMWOW. I'm not really great at acronyms, but it stands for AM Awareness, AM Outreach, an AM workforce. And that, of course, is where you all come in. For us to create an additive manufacturing ready workforce, we are doing this so that we actually create the people, we have the technology, it's on display, people are seeing it being used, and we will get those contracts. Most of these other sites, they are having to pipe in talent to do the work. They're setting up facilities, and they're bringing the workforce to those facilities. We create the place where the workforce already is, or at least fairly knowledgeable. That brings the plants. It's a completely direct equation here. And it's a huge money saver. We already have the workforce, even if they're not fully additive, but they just have some basic understanding and the training is that much easier, creates a great opportunity. This gets us contracts, this gets new facilities, and this is a big and here, it gives us more startups, which we're definitely in favor of. So we were actually Kentucky's first certificate. We actually created the entire certificate program for the state of Kentucky within the community technical system, and we did it back in 2014 to get the ball rolling. Our goal is workforce training. We've already trained over 1,200 students. Actually, we're closing in on nearly like 1,800 right now who have had what we consider additive literacy. They may not be complete experts, but they know enough to kind of get the ball rolling once they get into companies. And what does our training look like? Now, better way to say it is, this is what it doesn't look like. This is not what we do. Keychains, trinkets, a lot of spaghetti, absolutely not. People are basically out there with these 3D printers, taking this cutting edge technology and using it to create a poo emoji. And that is one of the biggest hindrances to all the companies in Kentucky who are thinking about this. This is what they're accustomed to seeing. So we have to stop that. It just completely has to end because it's not impressing anyone and it's not going to get us where we need to be. And it requires a different mindset. To get away from doing stuff like that, you have to be trained and understand the technology. So just because a person goes and buys a 3D printer is kind of a bad situation because they're not going to know how to do it correctly, they're not going to understand the science, and they can produce something, and they're going to be disillusioned in terms of its capability. Once you actually have the real training and the real expertise, which actually doesn't take that long, it can actually be done in one course, that's when you start making a difference. And so real AM work looks like this. We do quality control, we do checking, we test materials, we understand the materials themselves to make sure we're doing it right, we understand the processes. And very importantly, we use the design mentality to do it right. So that's how we build it into ours. And also, we are integrating our skills into other programs. We don't want someone just to come get a 3D printing degree. We want to do 3D printing with their primary course or program. We want our welders to understand 3D printing. We want our industrial maintenance or advanced manufacturing technicians to understand 3D printing. We want our CNC folks to understand 3D printing. And the fact of the matter is, by doing that, we are getting the skills into the companies whether they realize it or not. And so with that mentality, with that integrating of skills, is a win-win for employers. They're going to hire somebody that can do welding, and while they're doing their job, they say, you know what, I'm pretty sure we could 3D print that part. And the boss says, well, how much is it going to cost? And say, well, I can probably do it with a $400 machine. And then say, well, absolutely, let's do that. They do that, it saves them money, it means that they're moving in the right direction. For example, on the screen, this is a company we helped train. It took us about a day or two to train them. We helped them set up a $2,500 machine and start producing parts they needed. Within a year and a half, they had saved $200,000. In fact, the machine paid for itself in the first week of operation. Huge deal. It was such a transition that the head company, this was actually Harset Food Solutions, their head company turns around and sets up an additive manufacturing facility, I think it's in the Midwest, to support all their 26 locations with stuff like this. And that's generally what you see happen. Once they see the money, once they see the application, then they get excited and they scale up. Now, part of the story is also just awareness. And so you'll see we have all these social media accounts. And we definitely recommend that you friend us, like us, support us, etc. on here, because this is how we get attention for Kentucky. This is how we actually post out what is being done in real time, what is being done in high schools, what's being done at research institutions, and most importantly, what is being done within companies. The more we show that, first thing that happens is more entities like IMTS, ASME, the folks that actually matter, will see it happening and want to do follow-up articles, follow-up interviews, and they'll push it out on their platform, which gets the attention of the tier one companies. The companies, the ELCs, the folks that we work for, they're going to start to see story after story after story after story of this work being done in Kentucky. And they're going to be more interested in talking to us about locating operations or sending contracts our way. It is it's not going to be a flash pan kind of situation. We have to work hard at getting this technology out there. We're getting into the workforce as quickly as we can. We're spreading our courses or certificates all over the place. But at the end of the day, it's going to be the relentless self-promotion in a controlled, focused manner that's going to get us the attention that we want to bring those companies to us and know that we have a workforce to come and take advantage of within Kentucky and to locate their plants here. So at this point in time, I'll leave that up there. So at this point in time, I'll just entertain any questions that may come along. Okay, so question essentially is this, so where are we and what's kind of happening with Kentucky in general? So the way to think of it is this, you do have hotspots. University of Louisville is doing a great job in training folks in additive, but the problem is they're training folks that are turning around and leaving, going out of state, or they're coming from another state, getting the training they need and going back out. It does create an opportunity for a few sites to be located, a couple plants or a couple manufacturers to move into their area, but unfortunately that's only one area, that's not across the state. So we have a few companies here or there that are starting to integrate, and you'll find, in our region we have quite a few companies that have integrated and they are making money off this. Some of them are making money to the point they're actually hiding what they're doing so people don't realize the kind of money they're making. But that's only a few locations. We need more sites doing this. And the way to do that is to get a person who has some additive skills into a company and encourage that company to listen to them. Projects that we can do with companies. If we have more sites across the state that actually have the technology, bring a company in and say, hey, what's a part that we can produce for you? Let's get that going. And then we turn around and cycle it back through our media to push it out, not only statewide, but nationwide. We get more attention nationwide, that gets us where we want to be and more conversations started. And we need to really key on the companies we already have at our back door. Again, Stanley Black & Decker. Some of you all have them in your back door. You need to start having the conversation of what are your plans for additive and what can we do to help you with that? What can we do to make a deal with the fact that you want additive or you're starting to go in the direction of additive and we're creating the workforce that you need? So you need to reach out to the companies and find out more about what they're doing. And all you have to do, honestly, is Google 3D printing and the company name, and you'll probably find an article that will be a very interesting topic to have with them, or additive manufacturing. It kind of depends on where you're searching. But if you take a company's name, 3D printing, or the company's name and additive manufacturing, Google, and see what pops up, you might be surprised who's doing 3D printing in your backyard and have an opportunity there. Okay, so another question is that what is the basis for students to take the program? It's actually not a program, it's a certificate, and so anyone can take it. We assume that everyone's ground zero. Maybe they're coming to us from pre-engineering, maybe they're coming from medical tech, maybe they're coming from business or art. We start them off at the ground zero. They take the intro class, which gets them some basic additive literacy or 3D printing literacy, which also is computer literacy too. So it's a dual bonus if you need a computer literacy class. And then they can go to the next level and the next level and the next level after that. So we start from scratch with everybody, and anyone can get into learning this technology. I have a lot of folks who just take it who are retirees or are already on the job and take the class online. All right, so the question is the kind of equipment we're talking about. The equipment varies. A lot of what we do, especially in the early stages, is low-cost equipment, typically equipment that costs less than $500 per desktop printer. Some of what we're doing is $200 or $300. And we want people to use that as much as humanly possible because that trains in the mentality, and it's not about the high-end equipment. In fact, we tell companies, do not go out and buy. Don't let a salesman sell you a $200,000 or $300,000 piece of equipment. You do not need that, especially if you don't have anyone that actually is an expert at additive manufacturing. If they just say they have a 3D printer or they had a class or two, but don't have like generative or lattice structure, and they know what matters, don't go that route. You start off with low cost, you integrate, you make some success, then you go buy a high-end machine. So we start people from scratch, and yeah, that model is a little bit slower, but it's definitely in the larger spread and has the most potential for a success. And so it's a grassroots approach that it will gain momentum very, very quickly. Okay, others? Okay, so the question is, what kind of dollars are we dealing with here? And we're talking billions. I mean, when you look at the different projections that pop up left and right, we're already well past what the original projections were for the additive industry. And again, when you look at the things that Ford, GM, Boeing, Lockheed, when you look at what everybody is buying and doing, when you look at the fact that HP's out there selling 3D printers like mad, you just see that this is what's happening, and they're going to need a workforce to run those machines. And they're going to need folks to understand they're going to need welders to weld 3D printed parts. We're actually one of the folks that are kind of working on that quite a bit. We've actually been one of the first to actually do welded 3D printed parts off metal parts that were produced on a desktop printer. So huge possibilities there. Anything else? Definitely encourage you to take a look and join up with us on all those social media accounts. We publish out stuff that matters. We show student work for sure, but if it is anything that's relative to Kentucky, such as aerospace, manufacturing, DoD, this stuff that you need to see and you need to share, especially if some of these related companies are in your backyard. They need to know what's happening. So we encourage you to really join us up on social media, because it is a powerful, powerful tool to get the workforce up to speed. And the best part, it's free. So really take advantage of that. We actually even have a YouTube channel dedicated to training and improving people's use of the equipment and just making sure what people are aware of. One of the cool things that's happening about a new technique. One of our high school interns came in, replicated the technique, and actually made it better. And now the guy from MIT that published the real article is following our high school intern because of his breakthrough and expansion of what was previously done. So it's really, really awesome way to not only connect, but show the power of the technology. And the stuff that we're going to be doing with that is just flat amazing, which you can see if you hop on our social media. You can see the mesh stuff that we've done. Okay, so hopefully that makes that gives you a little bit of sense of what's going on, gives you some ideas of what's happening, and I appreciate the opportunity with everyone here to attending. And if you do have other questions, you can always contact us all the time, especially on LinkedIn. We'll be happy to help you, but keep this in mind. This is an opportunity for Kentucky like none other. East side, west side, wherever you want to go, this is technology that anyone can use and startups can take advantage of and get the ball rolling. So we don't want to miss the opportunity for Kentucky to lead the way. We're in a situation where no one else is doing this as a statewide initiative, and we are. This could put us on a map in a completely different way. Thank you all so very much for your time and appreciate it, and let me know if you have any questions. We'll see you.